Hello class, today we are going to start a new chapter, Structure of Atom. This chapter is important because over here we are going to learn important concepts that will help you in further chapters. So first we are going to discuss about spectrum. Okay, now let us try to understand what does this mean. A radiation which consists of one wavelength is called monochromatic light or monochromatic radiation. Light such as sunlight, which consists of radiation of different wavelength, is known as polychromatic. Polychromatic light, such as sunlight, when it makes to fall on a prism, then it will splits into a series of different colored bands. Consists of 7 colors of the sunlight named under Rydberg. 7 colors: violet, indigo, blue, green, yellow, orange, red. Now this series of 7 colors band is known as a spectrum. So the definition tells us the splitting of polychromatic light into its constituent radiations is called dispersion, and the pattern of radiations obtained due to dispersion is called spectrum. Now, unlike the solar spectrum, the spectra of atoms are not continuous, and atomic spectra are of 2 types. One we call emission spectrum and absorption spectrum. Emission spectrum, they are produced by analyzing the radiations emitted by excited atoms. So when the atoms are excited, the radiations they produced, that will come under emission spectrum. And these atoms can be excited either by heating the substance very strongly, or by passing electric discharge through a gas at a very low pressure, or by passing electric current through a thin metal filament. When the radiations emitted by excited substances, gas or vapors or chemical substances, are analyzed by a spectrograph, a discontinuous spectra consisting of a series of sharp lines and separated by dark bands is obtained. Such a spectrum consists of a few sharp lines separated by dark bands. It's called line spectrum. So we'll understand by taking an example of hydrogen spectrum. Hydrogen spectrum is an important example of line spectrum. The spectrum of hydrogen can be obtained by passing an electric discharge through the hydrogen gas in a discharge tube under very low pressure. Now, the radiation that will come out of this is made to fall on the prism, and this will separate or split into different color bands. Okay? So the lines that we might get will be like this. And over here, in case of hydrogen, we'll find 5 series of spectra. Okay? Lyman series, Balmer series, Gaussian series, bracket series, Poisson series. Okay, so these are the 5 different spectral lines. And these are the regions where it will find ultraviolet, visible, infrared, terrestrial, and infrared. Now these are the complete atomic spectrum of hydrogen. We have got a formula, okay? Or we can say the wavelength of the spectral lines of the different series can be calculated by a more general equation called the Rydberg equation. Well, let's see this. Has been put into one general equation where you will be helpful to calculate the wavelength. So it is given by 1 by lambda. This is R, we can say Rydberg constant, in bracket 1 by n1 square minus 1 by n2 square. Now over here, lambda is 1, this is Rydberg constant, n1 and n2 are the integers that may assume values from 1 to 3 up to infinity, and with the requirement that n2 value is always higher than the n2 or greater than the n1. N2 value is always greater than the N1. Say for example, if N1 is 1, then the value for N2 will be 2, 3, 4 like that. Not say and not less than that. Next we have got absorption spectrum. We'll come once again with this Rydberg equation. Absorption spectrum. When a continuous electromagnetic radiation, that is white light, is passed through vapors of an element or a solution of a substance, and the transmitted light is analyzed by a spectrograph, the spectrum obtained consists of some dark spaces. These dark spaces correspond to the light radiations absorbed by the substances. Such a spectrum containing dark lines due to absorption of light is known as absorption spectrum. Say for example, sunlight, when it is allowed to pass through a sodium chloride solution, the transmitted light, and if you need to fall on the prism, you find that it will give you two dark lines like this, which is an absorption spectrum. So as we discussed about the hydrogen spectrum 5 series, so it will be like this. So Lyman series, Balmer, Paschen, bracket and formula. Now over here, Lyman series, the value for N1 is always 1, and N2 can be 2, 3, 4, 5, 6, 7, 8. Okay. Similarly for Balmer series, the value for N1, the lowest value is 2, and the highest value can be 3, 4, 5, 6, 7, 8. Similarly, Paschen series, the lowest value is n equals to 3, n1 equals to 3, and it can be 4, 5, 6, 7, like that. Now, over here, in that hydrogen spectrum, say for example, if this is the nucleus, and outside we have got the orbits, first orbit, second orbit, orbit, like that. And if you have got one electron in the first orbit, now this electron, when you supply energy, it will be excited and it will try to jump from lower energy level to higher energy level. Now, when they jump from lower energy to higher energy level, they'll absorb energy. Now, when it loses that energy and when it comes back, then it will emit radiations of certain wavelength that will respond to the different spectral lines, we can say. So this formula, as we discussed just now, once again, because this equation is very, very important, we'll be doing the numerical based on this. So wave number, that is also equals to 1 by lambda equals to r, Rydberg constant, by 1 by n1 square minus 1 by n2 square, where r is a constant called Rydberg constant and is equal to 109678 per centimeter, or in meter we have got 10.9678 in 10 power 6. Okay. Now, as we know, we have got 5 series. This table will help you to understand about the values, and it will help you while doing the numerical as well. So please make a note in your copy. Series, say for example Lyman series. In Lyman series, the value for N1 will be, for all it will be 1, and the value for N2 for first line it will be 2, for second line 3, 4, 5 like that. Balmer series, the value for N1 is fixed, that is 2, and the N2 will be 3, 4, 5, 6. Similarly, Paschen series, the value for N1 is 3 for all, and N2 will be 4, 5, 6, 7. Okay, now this value will be using in the numerical. Now, assignment for today. Assignment number 10. Question number 1 is, what is solar spectrum? Question number 2, differentiate between emission and absorption spectrum. Question number 3, mention the name of series of line of hydrogen spectrum along with the regions. And question number 4 is, what is Rydberg equation? Give the equation and explain the terms involved in it. Complete this assignment and send it to my